Hey guys, this is 1.2. 1.2 looks like 1.1 from the very beginning. At the very beginning of 1.1, we did where we had to add up a list of numbers from one to something else, and that list of numbers was separated with little plus signs. Plus, 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 plus. Well, in 1.2, we're going to take this list of numbers, and instead of pluses, there's going to be commas. And then we have to figure out whether it's something called arithmetic or geometric. So in 1.2, we're keeping on with the list of numbers, but instead of plus signs, there's going to be commas. And then we get to do some other formulas when we replace these with commas. Okay, so if we look at 1.2 takes sequences and they group them according to whether they're arithmetic or geometric. And you might have heard people say arithmetic instead of arithmetic. It's the same thing. Okay, arithmetic just means the list of numbers differ by something being added or subtracted. And you can see that in this little formula. There's a big old fat plus sign right there. So that's how I can tell whether a sequence is arithmetic. You can plus something over and over and over. If we look at this geometric, it's not, I don't see a plus sign anymore. But I do see something in the air that's like an exponent. Yeah. Okay, so for arithmetic, the way we tell whether it's arithmetic is if you can add or subtract or minus, whatever you want to say. If you can add or minus the same number over and over again, it's called an arithmetic sequence. If you cannot add the same number over and over and over, say instead you can multiply or divide by the same number over and over. That's called geometric sequence. So let's look at this first example. It gives us a bunch of different sequences. See, it kind of looks like 1.1. There's just commas instead. And it says, in each of the following, list 3 terms that continue the arithmetic or geometric sequence. Identify the sequence as arithmetic or geometric. Okay, so like I said, arithmetic is when you can add the same number over and over and over to get a new number. So let's see what this first sequence says. It says we go from 1 to 13, and then from 13 to 25, and from 25 to 37. So ask yourself, can I subtract the same number or add the same number every time? It looks like from 1 to 13, I add 12. And from 13 to 15, I add 12. Sorry, 13 to 25. Then from 25 to 37, I add 12 again. So for part A, since we add 12 over and over and over, that means that sequence or that list is an arithmetic sequence. And that number 12 that you can add over and over and over, that is the letter D. It's the difference between the 1 and the 13, the difference between the 13 and the 25. Okay, so we were supposed to identify the sequences. Well, we did it. It's arithmetic. And we were also supposed to find the next 3 terms. Okay, well, let's see here. We had a 49 as our last term. So you're going to say 49 plus 12, and that's your next term. 61. Then let's go ahead and add another 12, because we have to come up with 3 numbers in the sequence. Then let's add another 12. It's kind of weird because I'm going side to side, but don't freak out. I know there's a lot of equal signs, but I'm just being lazy. Okay, so we have an arithmetic sequence. Yay. And the next three numbers in the sequence after this 49 are 61, 73, and 85. Okay, let's look at part B. Let's see, how do we get from 4 to 8 and 8 to 16? Well, I know to get from 4 to 8, you can add 4. But the only way this is an arithmetic sequence is if you add 4 every time. So let's see, from 8 to 16, do we add 4? No, we add like 8. So this is not arithmetic or arithmetic, because you cannot add the same thing over and over and over. Well, that means maybe it's geometric, where you can multiply or divide by the same thing over and over. So let's maybe see that. How do you get from 4 to 8 in terms of multiplying or dividing? You could multiply by 2 to get from 4 to 8. Then from 8 to 16, you could multiply by 2 again. So that means it's geometric. And that whole multiplying by 2 thing, that's the letter R up in this formula. We don't have to know it right now, but so R is this 2 that we end up multiplying everything by. Okay, so it's a geometric sequence. Then it says list the next 3 numbers. Well, we know how to do this. We're going to come up with the next 3 numbers in the sequence. And the way we're going to get it is we're going to multiply by 2. So 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. And hey, there's our next 3 numbers in the sequence. And it's geometric. Okay, let's look at this C, part C. Either we can add the same thing over and over, or subtract, either way, or we can multiply or divide by the same thing over and over. So let's see if we can do that. Let's think about addition first. To get from 18 to 25, you add 7. Same thing to get to 32, add 7. Same thing to get to 39, add 7. Okay, so since you add over and over and over, that means this sucker is an arithmetic or arithmetic. And that means to get the next 3 numbers, we just have to add 7 3 more times. So 46 plus 7 is 53. Plus 7 is 70, nope, is 60. Plus 7 is 67. Okay, if you see a list of numbers that you cannot add or subtract the same thing, or you cannot multiply or divide the same thing over and over, then it's called neither. So either you add or subtract the same number over and over, or you multiply or divide the same number over and over. And if you don't, it's neither. Okay, let's look at this next question. It has pictures. It says the first figure takes 5 matchstick squares to build. So if we look at number 1 down here, there's should be 1, 2, 3, 4, 5 squares made out of matchsticks, like those little pieces of wood that catch fire. It says 9 to build the second and 13 for the third. So this first one has 5, the second one has 9, the next one has 13. It says how many matchstick squares will it take to build the 12th figure? Okay, so it's asking not what the 4th figure looks like, not what the 5th, but what the 12th. And that thing's probably gonna be like massive, but we don't wanna know what it looks like. We just wanna know how many squares are gonna be in it. Well, look at these numbers, 5, 9, 13. Okay, ask yourself, how do we get from the 5 to the 9? And from the 9 to the 13? Can we do the exact same math over and over? And we can. To get from 5 to 9, you add 4. To get from 9 to 13, you add 4. So that's exciting, but we still don't want to draw all the way to the 12th figure. We're lazy. I'm lazy. So this is where we're actually going to use the formula. So since we could add or subtract the same number over and over and over, it's an arithmetic or arithmetic. Arithmetic makes you sound super fancy. Okay, so this is arithmetic, and the D is 4, and that's the difference. Like, how are they different? From 5 to 9, you add a 4, so the D is 4. Okay, so that formula up above for arithmetic says a sub n equals a sub 1. I'll explain what this means, calm down. A sub 1 plus parentheses n minus 1 times the D. Okay, so I know what this D is. It was this 4 from over here. We already talked about it. So let me put 4. Okay, now we just have to figure out what this N and this A1 is. Okay, well, A1 is the first number in the sequence. And then N is the number you want to find. That's kind of weird to say, but okay. So the A1 is going to be the first number from this list, not 1, 2, 3 from the matchsticks, but how many squares make up these figures, 5, 9, 13. So this 5, since it's the first number in the sequence, that's A1. Yeah. Then we already know D is 4. And then to figure out the N, that's whatever has the TH on it. So part A says how many matchstick squares will it take to build the 12th figure? That's what the letter N is going to be, 12. So let's plug in everything. We have A sub N equals the first number from the sequence, 5, plus parentheses N minus 1, where N is whatever has the on it, which is the 12th, okay? So 12 minus 1 times the D, which was 4. And then let's do this math. This gives me 5 plus 11 times 4. And that gives me 5 plus 44. And that's, oops, can't add, 49. And the way the homework might say it is, there are blank matchstick squares in the 12th figure, or it might say A sub 12 equals blank, and you put 49. Okay, part B says, how many matchstick squares will it take to build the nth figure? Well, that's pretty much the same thing, only we can't put a number in for that letter N. But all my other numbers are good to go. So for the 12th, or for the nth figure, I'm still going to say A sub N equals, I'm still going to say 5 plus, and instead of 12 minus 1, I'm going to put N minus 1. And it's still multiplied with a 4. Hey, that's the answer to part B. So because they didn't give us the 12th figure or the 13th figure, they just gave us an N. We just keep the N in the little formula. Okay, part C says, how many matchsticks will it take to build the nth figure? Okay, so far part A, B have been talking about matchstick squares, as in the amount of squares. Well, now part C is asking about just matchsticks. Oh no. Well, I think we have to redo this, okay? Or not A and B, but for part C, we have to redo it. Okay, for part C, it says how many matchsticks. So let's count how many matchsticks are in this first figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think I got 16. Okay, now let's count for the next one and the next one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think I got 26. And the next one should be 36. Let's check. 36. Woo! Okay. So now it says, how many matchsticks will it take to build the nth figure? So we're going to come up with a formula just like this. A sub n equals blah, 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 and we're going to keep the letter n in there because it said nth figure. But the thing that's going to change is the 5 is now whatever my first term is. So a sub n equals, my first term is now not 5 anymore. Since we're talking about the amount of matchsticks, it's 16. Plus, we still have n minus 1. But then the d is how much each number is different. So how do we get from 16 sticks to 26? And from 26 to 36? You add 10. So that's going to be the letter D. And that's the answer to part C. So for part C, since they're not talking about matchstick squares, they're talking about actual just matchsticks, we had to count every little stick. Then whatever the amount of sticks was from the first figure, that's what a sub 1 is. And then however many numbers are different from 16 to 26 and from 26 to 36, that's our D, or 10. Okay, let's keep going. This next one says, find the first five terms in sequences with the following nth terms. Okay, so we just have to come up with 5 numbers in a list that come from this little formula right here. So what we're going to do is first let's work on this 3n squared plus 1. And remember, we need 5 numbers in a list of sequences. Okay, well, to get this first number, you're going to plug in 1 into this equation. So 3 parentheses 1, close parentheses squared, plus 1. And then you're going to put that in the calculator. Or if you want to try and use your brain, do 1 squared first. 1 times 1 is 1. Then multiply it with the 3. 1 times 3 is 3. Then plus 1 is 4. So if you're going to do it in your brain, do the exponent first, 1 squared. Okay, then we're going to plug in a 2. 3 times 2 squared plus 1. And then put that in the calculator or your brain. But we should get 13. Then we're going to plug in a 3. And then a 4. And then a 5. We should get 19. $49. 76. Okay, then you're going to do the same thing for all these others. Part B is 7n plus 5, and you're going to do the same thing. You're going to plug in a 1 for this 7n plus 5. So 7 times 1 plus 5, and that should give me 12. Then we're gonna do 7 times 2 plus 5, and that should give me 19. And then you keep going. So I think this will be 12, 19, 26, 33, and maybe a 40. Okay, good. The only one you will probably have trouble with is part C, just because it's a weird button in the calculator. So let me show you on the calculator. Okay, if I want to plug in a 1 here, you have to do 10 to the 1 minus 10. And if you're putting that in the calculator, we use the up button to get this 1 in the air. So I press 10, and then this up button by the divide, up, and then 1. And 10 to the 1 is 10. Minus 10 is just 0. Then I'm gonna plug in 10 to the, now plug in a 2. 2 minus 10. And 10 squared is 100. Minus 10 is 90. Then you do 10 to the 3 minus 10. And I think that gives you 1,000. Minus 10 is 990. And then we keep going. So I think this list of numbers would be 0, 90, 990, 9990, and then 9999. I think you just have to add zeros every time, or add 9s every time. 1, 2, 3, 4, 5. But y'all will have to check my math. Okay, so all you do is plug in the number 1, 2, 3, 4, 5 in for whatever equation they give you. We knew we had to plug in the numbers 1, 2, 3, 4, 5 because they said find the first 5 terms. If they would have said plug in the first, or if they would have said find the first 6 terms, I would have plugged in 1 all the way to 6. Okay, let's look at this next sucker. It says, how many ways can you make change for 85 cents using only nickels, dimes, and quarters? Okay, make change means we come up with all the different combinations that could add up to 85 cents. Okay, so let's get started. We have 1 quarter and 6 dimes. That makes like 25 cents plus 60 cents is 85 cents. Okay, let's try 2 quarters. 2 quarters is 50 cents. And then you could have 3 dimes, because that's 30 cents, so that would make 85 cents, and then I would need, nope, that would make 80 cents. Then I would need 1 more nickel to get 85 cents. Yeah. Or I could have 2 quarters, and let's see, a bunch of nickels. I could have 7 nickels. Because 7 nickels would be 35 cents, plus 50 cents from 2 quarters is 85 cents. Okay, let's keep going. We could have 2 quarters and 3 nickels. What would that be? That would be 50 cents. Plus 3 nickels is 15, and that would add up to 65, so I could have 2 dimes. Or let's keep going with 2 quarters. 2 quarters, I could have 5 nickels. Let's see what happens. 2 quarters is 50 cents. 5 nickels is 25 cents. That would give me 75 cents, and I could still have 1 dime to make 85 cents. So I think this is all the possibilities of quarters. Let's try, of 2 quarters. Let's try 3/4. If I had 3/4, that means it would be 75 cents, and I would have 10 cents to make up. So I could either have 1 dime, or I could have 3/4 and 2 nickels. Okay, now let's talk about 1/4. That's gonna take a while. 1/4, that's 25 cents. And then to get to 85 cents, I could have straight up 6 more dimes and 0 nickels. Or let's see, what if we had 1/4 and 5 dimes? How much would that be? 1/4 is 25 cents. 5 dimes is 50 cents. That would make 75 cents, and I could have 2 nickels. Let's keep going. 1/4 and 4 dimes. That's 0.25 plus 0.40. That's 65, and that's 20 cents away, so I could have 4 nickels. And then keep going. 1/4 and 3 dimes. That would make 0.55, and then I could have 6 nickels after that. And then we keep going. 1, 2. Let's see, we have 1/4 and 2 dimes. That makes 45 cents. And then for nickels, it would be 8. And then we could still have 1/4 again, 1 dime, and this time it's probably gonna be 10 nickels. Let's see. Yep, okay. Or we could have 1/4 and 0 dimes and a boatload of nickels. $12 Okay. Let's see. So we've talked about 2/4, 3/4, 1/4. I think we just need to talk about any of the 1/4s that I've left off. So let's see here. We're supposed to have 21. Okay, now let's talk about 0/4. If you had 0/4, then for dimes, you could have 8, that would be 80 cents, and then 1 nickel would be 85 cents. Or you could have 0/4, 7 dimes, and 3 nickels, and then we could keep going. 6 dimes would be 60 cents. You need 25 cents. And then hopefully you can see the pattern. We're going 8, 7, 6, and my nickels are going 1, 3, 5. That happened over here. My dimes went 6, 5, 4, 3, 2, 1, and my nickels went 0, 2, 4, 6, 8, 10. They went up. So we can use this same pattern. This can be 0, 5, 0, 4, 0, 3, 0, 2, 0, 1. And then how about 0, 0, and then the nickels are going to go up by 2. So 7, 9, 11, 13, 15, 17. Okay, let's see how many I got total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think I have 1 extra. What's the one I have extra? No, I don't think I have 1 extra. Okay, so anyway, let's count up our goodies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. What do I have extra? That's out. Okay, and I think I have 22 different versions. Woohoo! Okay, that's all of 1.2. What you need to remember in 1.2 is if they want you to find a number in the list, then you look for whether they say the first 5 terms, and that's when you plug in 1 through 5, or you look for where it says the TH, like 12, so we plugged in a 12.